rest of the explanation. Okay, the rest of the explanation. Okay, so this is for the remaining part of section 12.6. Okay. Okay, now just we'll start this section now. This is chapter 14, the first section of chapter 14. And in fact, really, you can say, no, really, we just started Math 201. So Math 201 basically is section chapter 14 and chapter 15. The previous two chapters were prerequisite materials for these two chapters. So the real Math 201 is really chapter 14 and chapter 15. Okay. Now let me give you a brief introduction just to understand the title. A brief introduction of what we are going to do in chapter 14 and chapter 15. Now here we remember in orientation and in freshman, we will deal mainly with functions of this form, y equals of x. X is called the independent variable, y is called the dependent variable. And we say y is a function of x, or we say it is a function of one variable, a function of one variable. Okay. A concrete example of functions of one variable, if we take a square, for example, here a square with side x. When if you ask about the area, what is the area of the square? It is x squared, x squared. So the area of the square depends on the sides of the side of the square. Since the area depends on the side, we write it as a of x. To indicate the area depends on x, The value of the area depends on x. How? Through this relation, x squared, x. A of x. The area depends on x. The size, the length of the side of the thing equals x equal. This is the applied example. Now in mathematics, we write this in general as follows. Okay, we say y equals f of x. So y could be anything, x could be anything. Okay, we say a variable, a quantity depends on another quantity through some relation. So we say y equals f of x, or y is a function of one variable x. Okay. So this is S for functions of one variable, or for the familiar functions we were working with in orientation and freshman. Now we make generalizations. Now if you take a rectangle, okay, x, y, length and width, x, y. What is the area of the rectangle? It is x times y, okay. So the area of the rectangle depends on two quantities, x and y. Depends on two quantities, and x and y are independent quantities. So we write this as a of x, y. To indicate the area depends on two quantities, x and y, through the relation x, y. Okay. We generalize it in mathematics. We write of x, y, of x, y, and we put a value for this function, because it's z. Okay. So here we write y equals of x, and we write z equals of x, y. So z, the value of z depends on two quantities, x and y, or two variables. Okay. So we say z is a function of two variables. Y is a function of one variable. Here, z is a function of two variables, x and y. I.e., z depends on two quantities, x and y. Okay. You can go further. If you take a box, this is a box with size x, y, and z. What is the volume of the box? Okay. It is x, y times z. Okay. So the volume of the box depends on x, y, and z. So I write it as in the following way. Okay. V, the volume depends on three quantities, x, y, and z, through the relation x, y, z. Okay. The volume depends on three quantities through this relation. We generalize it in mathematics. We write it as of x, y, z, of x, y, z, and give it a name w. So where w the value of w depends on the values of x, y, z, three variables. Or we say w is a function of three variables. Okay. So here we say w is a function of three variables. Here we say z is a function of two variables. In orientation, we say y is a function of one variable. Okay. Functions of two and three are, and of course, you can see, you can generalize, you can consider functions of four variables, five variables, several variables. Okay. So this is now the title, functions of several variables. Okay. You can generalize it. Now, mainly we will work with functions of two and three variables, mainly. Okay. in chapter 14 and chapter 15, we'll work with functions of 2 variables and functions of 3 variables. Okay. This is mainly what we will work with. Okay. Now, when you say we will work with this, what are we going to do with these functions? Functions of 2 variables and functions of 3 variables. Okay. The brief answer in chapter 14 and chapter 15, whatever we did with functions of 1 variable here in orientation and in freshman, we will do them now with functions with functions of 2 variables and functions of 3 variables. In orientation, we ask about domain, range, graph. In freshman, we ask about limits, continuity, differentiation, integration, and applications. We'll do all of this with functions of 2 and 3 variables. Okay. And this is the content, briefly, the content of chapter 14 and chapter 15. Okay. So this is the introduction of this chapter, of the 2 chapters, 14 and 15. Okay.
The application
you will see, you will have applications. Yes, you will have applications. Yeah. As we go on, طبعا not now. Okay, as we go on. Okay. Okay. So this is the introduction here. So if the introduction is clear, if the introduction is clear, you can just write 1 in the chat. Okay. The objective of chapter 14 and chapter 15 is to study functions of 2 and 3 variables, basically. Okay. Now today we'll start with orientation questions about functions of 2 and 3 variables. Orientation questions, functions of 2 and 3 variables. And the orientation question, again, just pay attention. It is very important to know number 1 here. This is introduction. Still, we are in the introduction. But it is a basic introduction. Okay. Now here you have the following. You have the following here. Let me write this. Just a simple table here. Okay. Simple table. Okay. Again, you start with the orientation. Y equals of x, function of 1 variable. And we take the terminologies: independent variable, okay. What is the independent variable for this function here? Okay.
Y.
X, independent, x, okay, x. What is the dependent variable? Okay. Y, okay.
Y.
So لاحظ هنا y, the value of y depends on the value of x. So y depends on x. We call it dependent variable. Okay. What is the domain in general for a function of 1 variable? What is the domain in general? Okay.
X.
And the values of x. What are the values of x usually? They are what? Okay. Real numbers, near real numbers. Okay. On the x-axis, And the domain, the possible values of x. Usually they are real numbers, but it could be maybe the whole real numbers from -infinity to infinity, or maybe just an interval from a number to a number. Okay. But the domain will be always, the values of x will be real numbers. Okay. On the x-axis. Okay. What is the graph of a function of 1 variable? What is the graph in general? Okay.
Straight line.
Always a straight line. Well, it is a curve in general. Okay. A curve. A line is a curve. A line is an example of a curve. So the graph will be a curve in the xy plane. Okay. In the xy plane. And when you go to the graphs, just 1 minute here. Let me take this here and here. Okay. For functions of 1 variable, the graph is the following. To make the graph, we make an axis, 1 axis for the domain, which is the x-axis, 1 axis for the range, which is the y-axis. The y-axis is perpendicular to the x-axis. Y equals f of x, and you just, the graph will be a curve, something like this, okay. At a point in the domain x, there is a corresponding point y in the range, and then you have a point here x, y, in the curve, on the curve. So this is the typical situation for functions of one variable, okay. It is clear, and it is not new, you already know this, okay. Okay, now we go to the generalization. Pay attention to the generalization. This is easy as you because you are familiar with it. But once you understand it, you will see the generalization is obvious. Okay. Now we got two functions of two variables, and they are written as follows: f of x, y, and the output or the range z. Okay, z. Okay. So z is a function of x and y. Z is a function of two variables, x and y. What are the independent variables here?
X and Y.
X and Y, X and Y. I have to substitute X and as a value for Y and a value for X, okay. What is the dependent variable? It is H, Z, okay. Z depends on X and Y. The value of Z depends on X and Y. So the dependent variable is Z, okay. What is the domain in this case? What is the domain, okay?
Value of X and Y.
Of course, then you have to substitute a real number for X and a real number for Y. صح ولا لا? You have to substitute. يعني the input consists of two numbers. And then orientation, the input consists of one number. Here the input consists of two numbers. I have to substitute a value for X and a value for Y. These two numbers, we combine them together to form a point. Points X and Y. In the XY plane, in the XY plane. Okay. So the domain will be points of two numbers, points consisting of two numbers. Okay. And you combine, you will feed up. You put the input as a real number for X, a real number for Y. You put two numbers, two real numbers. You combine them and you say it is a point. So the domain will be points. The domain will be points in the XY plane. Okay. What is the graph of a function of two variables? In general, to be a surface in a 3D space, a surface in general. Okay. Now, what is the shape of the this general graph? You pay attention. You have you have x value, y value, z value. The domain x and y in the XY plane. The range حتكون ايش? The dependent variable z. Okay. So you have three variables, so I have to have three axes. Two axes for the domain and one axis for the range. The domain comes from the XY, okay. So we do the following. For the domain, you write this is the y-axis and this is the x-axis. So the domain values will be points in the XY plane. I will write it as a plot. And I need a third axis for the range, for Z, the values of Z. You just draw a perpendicular line through just draw the Z-axis perpendicular to the XY plane. Okay. So the domain will be in the floor, points in the floor. The range will be along the Z-axis. Okay. The general graph is a surface. You just graph a surface, something like this. This is a surface. Okay. Now take a point in the domain. A point in the domain will be something like this: X and Y. لاحظ هنا. Okay. Domain points XY in the XY plane. XY, they will form a point in the XY plane. So the domain will be points in the XY plane. Now the range value, just when you substitute in the XY, you get a value Z. Okay, so you have a point here in the surface حتكون X, Y, this is the domain, and Z, the third coordinate. This is the corresponding point on the surface. Okay. Domain will be in the floor, points in the floor, points in the floor. This is the domain. Points XY in the floor, in the XY plane. Okay. For each point, you will have a point in the range Z. Then you get a point on the surface XYZ. Really similar to orientation. Domain, range, a point in the domain, corresponding point in the range. You have a point XY in the curve. A point in the domain, XY, corresponding point in the range, Z. Then you get a point in the surface, XYZ. Okay, XYZ. هن اوكي.
الدومين الآن يعتبر يعني نقطتين بس فقط اكس واي. الرينج 3 نقط اللي اكس واي زد.
لا لا لا، هذا الرينج، هذا البوينت، هذا بوينت اون ذا سيرفيس، هذا الدومين الاكس واي، وهذا الرينج زد، الرينج زد اوكي. then you get a point in the surface x y z.
ممكن توضح أكثر يا دكتور؟ ما فهمت.
خلاص لا لا انتبه، هذا الاورينتيشن، روح الاورينتيشن، هذا الجراف اللي هنا اوكي. هذا x axis for the domain, y axis for the range. Take a point from the domain x. What is the corresponding y in the range? Y. X, Y, they form a point in the graph, on the curve. X, Y is the point, the corresponding point is the curve. The same thing here. The domain point will be, the domain حتكون a point x, y. The range z. They combine into a point in the surface. What are the coordinates of the point in the surface? X, Y, z. Exactly like this one, generalization. From a curve to a surface. That's it. And what is the difference only? Just in the domain. Here you have a number. Here you have a point in domain. The domain will be a point, okay, or consist of points, okay. Everything else is the same, okay.
تمام واضح.
يعني هو الأساس هو هذا، هنا الأساس. Math 101 orientation. الآن generalization. Generalization لا أكثر لا أقل، okay. But make sure this is clear, because this is really what you need in chapter 14 and chapter 15. And this is what we'll have. This is the typical situation. And this will come up. We'll use this again and again as we go on. This is the main part. This is really the main part. Okay. Now we go to the third case. We have functions of the three variables of x, y, and z, and the output or the range is w. What are the independent variables? X, y, and z. X, y, and z. What is the dependent variable? W. W depends on these three values. So the dependent variable is W. Okay. Okay. Now what is the domain? What is the domain here? Okay.
Domain.
Point X.
You are now putting, you are substituting array number for X, array number for Y, array number for Z. So you have a points of three coordinates. Okay. هتكون points, again points, X, Y, Z. In a 3D space, يعني the independent variables هم for the domain, dependent variable for the range. Okay, so I need to feed three numbers. These three numbers will form a point in a 3D space. Okay. What is the graph here? What is the graph? Okay. Now to graph this one, I need how many axes? I need 4 axes. One for x-axis, one for y, one for z. يعني 3 axes for the domain, and 1 axis for the range. For the domain, this is H for the domain. X, Y, and Z. They are in perpendicular to each other. Now for the range, I need to draw an axis or a line perpendicular to the x-axis, perpendicular to the y-axis, perpendicular to the z-axis. So how can you draw a line perpendicular to the 3 coordinate axes? Okay. And I need a line for the range. It has to be perpendicular to the x-axis, y-axis, z-axis. Okay.
From the origin.
Okay. Okay. From the origin to what? Okay.
Extend to
كيف؟
extend to infinity.
يعني in which direction? In which direction?
Volume.
اوكي لو سويت كده مثلا to infinity، هل هذه 90؟ ما هي 90. هل هذه 90؟ ما هي 90. اوكي.
دكتور
ها؟
تبي at the same time.
Yeah, they are perpendicular to all of them. يعني the axis for W has to be perpendicular to the 3 axes.
يكون out of the base.
Like the orientation هنا لاحظوا range domain they are perpendicular. The range is Z, domain x axis y axis. لاحظ Z is perpendicular to the x axis, Z is perpendicular to the y axis. Okay. And we have to do the same thing. Okay. You think about it in the يعني during your lunch time مثلا, think about it. You see it is not possible. Not possible. Okay. You cannot do this. Okay. Because our space is a 3-dimensional. It is not 4-dimensional. It is not 4-dimensional. So really, we cannot graph such function. Okay. So what is the graph? We cannot graph it, but in mathematics they call it a hyper surface in 4D space.
حتى بالكمبيوتر يا دكتور ما تقدر
حتى في الكمبيوتر. اوكي. If you can do something by computer, then you can do at least partially in our world. Okay. فهنا you can. So it says a hyper surface, meaning a surface in a higher dimensional space. Hyper معناتها higher. Okay. Hyper surface معناتها a surface in a higher dimensional space. Okay. So in this case, really, we cannot ask you to graph because you cannot graph. You cannot graph functions of 4 variables. Okay. So this is ish. So mainly for the graph, just for functions of 2 variables. For functions of 2 variables, z equals of x, y. Okay. So this is ish. This is the explanation. Now let me give you concrete example just to illustrate this at least. The examples here. Examples. 1 of xy equals 4x squared plus 5y squared. So it is a function of 2 variables. We ask the orientation question. The first question, domain. What is the domain of this function? Okay. What is the domain of this function?
It is the set of points.
I see. Okay. Always you write points x, y, in R2. Okay.
where x and y to the 0.
Yeah. لا تنسى. Domain will be points for functions of 2 variables. xy in the xy plane. Points xy in the xy plane. Now when you write it as xy in R2, and then you have 1. Now, what are the possible values of x and what are the possible values of y? What can you substitute for x and what can you substitute for y?
All real numbers.
Real numbers.
X can be any real number minus infinity to infinity, and y is also any real number minus infinity to infinity. I can substitute any real number x, any real number y. When you combine them, you get points. Okay. Now, this domain here, can you describe it in word? When the domain will be in the xy plane, the domain will be in the xy plane. Now, will it be the whole xy plane or part of the xy plane?
And the first octant.
Part
ولا whole؟
No, ده
part because it's positive.
ايش وين البوزيتيف موجود عندك هنا؟
هول يا دكتور.
اللي قال لك x minus infinity to infinity, y minus infinity to infinity.
كله.
Everything. Okay. صح ولا؟ the entire xy plane, the entire xy plane. And take all x and all y minus infinity to infinity. So everything. Okay. I can substitute any x and any y. I will cover the whole plane. The whole plane. Okay. Now, what about the range? What is the range of this function?
Only greater than 0.
هذا بوزيتيف هذا بوزيتيف صح ولا؟ كلهم بوزيتيف. Okay. So هنا ناخذ هنا as x 4x squared plus 5y squared greater than or equal to 0. يعني the possible values of y of z عفوا حتكون greater than or equal to 0. معناته 0 to infinity. 0 to infinity. Okay. Because whatever you substitute here, you will end up with 0 or positive. The possible values of f, the range, حيكون 0 to infinity. Okay. Now, what about the graph? Okay. And for the graph, pay attention. And it is really, for this one, it is easy. It is a familiar graph. فأنا remember إنه write z equals of xy صح ولا لا؟ This is actually the notation for functions of 2 variables. فالf here عبارة عن z. So you just becomes ايش؟ This implies z equals 4x squared plus 5y squared. Okay. So this is really the equation of our graph. Okay. Now, what is the graph of this equation here? Okay.
elliptic paraboloid.
This is what we did in the previous section صح ولا لا؟ Okay. Z equals elliptic paraboloid. This is what I explained in detail in the last section, in the last lecture, okay? But this is elliptic paraboloid, so you know how to graph an elliptic paraboloid, okay? This is x, and this is y, and this is z. Just a parabola here, and this is h. You close it with an ellipse. An elliptic paraboloid, an elliptic paraboloid. Okay. Now we see, in the last section I said it is a very important section for the basic graphs for chapter 14 and chapter 15. Now this is the first example for the importance of section 12.3. So this is the graph. We can graph it because this is just an elliptic paraboloid. Okay, before I go to the next example, pay attention يعني هنا الآن the domain will be the xy plane, the whole thing, the domain, okay. And the graph is this one, okay. You remember in orientation also, one way to find the range is to find the range from the graph, صح ولا لا? Okay, if you know the graph, you can find the range. Now from the graph, what is the range? What are the possible values of z? From 0, the origin, to infinity, okay. The graph will extend for infinity. So it's from 0 to infinity. So you can get also the range from the graph, from the graph, okay. بمعنى آخر, يعني you will see really many of the generalizations. Many generalizations of orientation and in calculus will be carried over here, okay, in chapter 14 and chapter 15. Many generalizations. خلنا نقول لك يمكن 70% أو 80% of what we will do in chapter 14 and chapter 15 will be generalizations of what we did, in freshman and orientation. Many of the ideas, okay. Now let me give you another example here too. Of xy equals root 9 minus x squared minus y squared, okay. Domain, what is the domain? Again, always point xy in R2. Okay. What are the conditions on x and y? What are the conditions on x and y?
minus 3 to
No.
Greater than
Six.
Exactly. Orientation. In orientation, if you have something inside the root to find the domain, you have to put whatever inside the root greater than or equal to 0. You do the same thing here, okay? Same rules, nothing new, okay? هتكون 9 minus x squared minus y squared. It has to be greater than or equal to 0. Whatever inside the root has to be greater than or equal to 0. This is xy in R2, such that I can write it as x squared plus y squared less than or equals 9. Okay. The domain will be the set of points x, y, satisfying this inequality. Okay. Question. Now the domain. Will the domain be the whole xy plane or part of the xy plane? Okay.
part.
If it is part, which part? Which part of the xy plane? Okay.
Inside the circle.
فأنا pay attention. Yeah, okay. طبعا هنا the graph will be something like this. طبعا not the graph, just you have to write the xy plane, x and y and z. And the domain will be in the xy plane. Okay, the xy plane. Okay. I need to sketch the domain here. Which part of the xy plane? Usually, if you want to sketch the domain, don't sketch it in 3 space. Just take the xy plane. Take the floor, because the floor is the location of the domain. So take the floor just to see the picture of the domain. This is x and this is the y, okay. But this is the domain in the xy plane. I need to sketch this inequality here in the xy plane to know what is the domain, okay. Well, how to sketch x squared plus y squared less than or equals 9, okay.
Known as
Circle.
If it is equal, if it is equal, it حتكون a circle, but it is less than or equal, okay.
من الثلاثة لين الأقل.
يعني
فانتبه, very simple, pay attention. x squared plus y squared less than or equals 9. You sketch the equality. حتكون a circle. So this is a circle, center the origin and radius 3. Radius h 3 minus 3, 3, 3 and 3. This is if it is equal. حتكون just a circle. حتكون just ايش a circle. A circle. But it is less than or equal. حتكون ايش؟
all inside the circle.
inside or outside the circle؟
Inside.
Inside.
حتكون inside. Okay.
Inside.
Inside. So everything inside the circle. Okay. Okay. يعني the domain will be a disk. The circle and everything inside it. Okay. واضح ولا؟ It is less than or لما تكون equal, very simple as circle, the usual thing. Now less than or greater than حتكون either inside or outside. Okay. If you are in doubt هل هو inside ولا outside, what should you do? Okay. Choose a value, any value here. Okay. For example, the origin 0, 0. Okay. Is it in the domain or not in the domain? Well, how to check whether it is in the domain or not? I check the inequality. Yeah. Does the origin satisfy this inequality or not? Okay. You substitute, you get h 0 square plus 0 square less than or equal is 9. Is this true or not true? Okay.
True.
0. Then it is h and just the inside. Okay. And checking one point is enough to decide whether it is h inside the outside the thing. So this is the domain. So the domain will be a disk. It is not the entire XY plane. It's just a disk. Okay, of center, origin and radius 3. Okay. This is the domain. Okay. What about the range? What is the range? Okay. Maybe it is not easy, the range. Okay. Okay. So if it is not easy, try to get it from the graph. From the graph. Okay. From the graph. Graph. How to graph it? We do as we did above. F of xy عبارة عن z. فأكتب z equal 9 minus x squared minus y squared.
sphere with radius 3.
Yeah, let's see. Okay. F of xy عبارة عن z. Fine. This is now okay. Now what is the graph of this one? Okay. If it is clear to you, fine. If it is not clear, how to just make sure or to convince yourself with the graph, just square both sides. Is it squared equals 9 minus x squared minus y squared. So this implies x squared plus y squared plus z squared equals 9. Okay. What is this?
Sphere.
What is the graph of this equation? This is a sphere. This is a sphere. A familiar sphere. Sphere of center, the origin, and radius 3. Okay. So this is the sphere. Okay. 3, x and y, and this is z. Okay. So this is a full sphere. Now we go back to the original equation here. Okay. The graph of the original equation, will it be a full sphere or part of a sphere? Okay. What do you think?
Part.
Which part?
The positive part.
Upper part.
نحن z equals root, ف z is always positive, صح ولا? It is not negative because it is root. Okay. بما إنه positive, z is positive, so I take the part of the sphere with z positive, which is the upper part. Okay. I write it in this manner here. So something like this. This is x, this is y, and this is z, and this is h. What you have? 3, and 3, and this is h. This is h. Okay. So it will be the upper part. Okay. So this is the domain. Okay. This is the disk, the domain. This is the domain. Okay. Domain. Okay. In the floor, which is what we did here. The domain, we find it a disk in the XY plane. It is this one here, the dashed line. So the floor, the dashed region, the floor, this is the domain. And this is the graph. It is the upper part of a sphere, the upper part of the sphere. Okay. Now from the graph, what is the range? What is the range? What are the possible values of z? Okay.
0 to 3.
0 to 3.
0 to 3.
Let's go farther than 3. صح ولا? From 0 to 3. From 0 to 3. Okay. هتكون the range هتكون 0 to 3. From the graph. Okay. So again, this is a basic graph. Okay. Now let me take a third example here. 3. of xy equals 1 over absolute value of x minus absolute value of y. Okay. What is the domain? What is that domain? Okay. Again, you start with what? First. What should I write here? What should I?
Points.
Points. لا تنسى. Always the domain with points حيكون x, y, and r2 and r2. Now, what is the condition in x and y? That's it. What is the condition in x and y?
Greater than 0.
greater than
X
0.
minus y.
Oh, no, لا تقرأ. هل في روت هنا؟ ما في روت.
Greater
No,
than
not
one.
equal, not equal to 0.
The
The
denominator not
denominator
equal 0.
equal 0.
Not equal to 0. So it's absolute value of x minus absolute value not equal to 0. You write it in this manner here. This is x, y in R2 such that absolute value of y not equals absolute value of x. Okay. This is h absolute value of x, xy in R2 such that. You remember in orientation, when you have absolute value of a equals absolute value of b, this means a equals plus minus b plus minus b. فهنا I can write it without absolute value. حتكون y not equals plus minus x. Okay. Plus minus x. Okay. This is the domain, all x, y, and all points in R2 such that y not equals plus minus x. Okay. Now, the domain, will it be the whole xy plane or part of the xy plane? If it is part of the xy plane, which part of the xy plane? Okay. This you should know. You should be able to know. Okay. So how to sketch the domain? How to sketch that domain? Okay. But when you have y not equal, just write in a y equals x, and y equals minus x. Okay. You have two lines, y and in the xy plane, the domain will be in the xy plane. So this is the xy plane. You graph y equals x. This is y equals x. And this is h, y equals minus x. Minus x, okay. Now you have two lines. Now question, are the points on these lines in the domain or not in the domain? Okay.
Not.
No.
No, not in the domain.
Why not equal? They are not on the domain. Okay. What about the point? This is why I wrote them dashed. Okay. Dashed. What about the points not on the lines? What about the points here, for example? Are they in the domain or not in the domain? Okay.
Yes.
Yes, in the domain.
What here? Yes.
Yes.
What about
They
here?
are.
So, okay. All of these are in the domain. All of these. If you want to describe the domain in word, x, y, and R2, the domain consists of all points in R2, all points in R2,
Except
such that y not equals plus minus, i.e. not lying on the two lines, not lying on the two lines, not lying, not on the line, not on the line, not on the lines y equals x and y minus x. Everything except those on the lines y equals x and y minus. So these are dashed line. Okay, you shade everything except the two lines. Okay, so this is the domain of this function. Okay. What about the range? Well, it is not easy. What about the graph? Again, it is not easy. So we'll not ask you. If it is not easy, we'll not ask you about the graph and about the range. Okay. But this is h number 3. 4. Okay, for example here, we have f of x, y, z, f of x, y, z equals x over z minus y. Okay. What is the domain? Again.
Domain z and z minus y not 0.
Before condition, you have to write h هنا.
Point.
Set of points.
X,
X,
y.
y, z, x, y, z. So they are points. Okay, x, y, z. Any 3 space R3. Okay. Now the condition. What is the condition?
X it belongs to R and z minus y not equal to
Z
0.
minus y not equal
enough to
0.
say z minus y not equal to 0. This is enough. Okay, z minus y not equal to 0. This is h x, y, z. okay, in R3, such that Z not equals Y, not equals Y. X, there is no mention for it, but it is a free, okay, it is a free, okay. I need just to concentrate on what is the important, what is the H, no, Z not equals Y, to avoid me having 0 in the denominator, okay. So this is the domain, okay. What is the range? What is the range? Okay. Again, it is not easy really to find the range. It's not easy. What is the graph? It is a function of 3 variables, so you cannot really graph it, okay. The range, we can find it in fact, but it is not required from you. The range in fact is minus infinity to infinity. It is optional. I wrote the answer in the explanation in the note, but it is optional. Yani. We don't need to know it. It is not H, it is not always easy, okay. So to summarize now, for the 4 functions of 2 variables and the 3 variables, the orientation equation consists of 3 questions: domain, range, and the graph. We can always ask you about the domain. The range and the graph, no, it depends. Sometimes we can ask you, sometimes we cannot ask you the domain and the range. It depends on the simplicity of the
What can I know, دكتور؟
كيف
أعرف يعني إذا هي
يسألك إذا سألتك find the range معناتها you should be able to. If I did not ask you, that's it.
القصد إنه وش المفروض أحيط بأن من هالناحية هذه، من ناحية الرينج، يعني ليكون أنا على دراية فيه.
No, everything you did in the orientation, the simple things in orientation يعني ما في أي حاجة.
أوكي.
أنت you check the exercise in the textbook and also in the note, you will see whether you can or not. And sometimes we can, but it is hard, so it is not required from you. Okay.
Okay.
Now, in the as you notice, now هنا observation and next observation. At the end of this section, 12.14.1, as usual, there is a section on more examples. صح ولا لا? More examples حيكون okay. In the section of more examples, again, you have to know the domain. But the range is optional also. The range is optional in this section. For this section, on more examples. If you are interested, you can read the range, and it is something extra for the interested students, okay. But it is optional. It is not easy for you to really visualize it or find it easily, okay. But it is. I wrote the range also. If you are interested, you can read the range, okay. So this is for this section, okay. So let me just again just recall what I mentioned in the beginning. Just let me repeat what I mentioned in the beginning again. For the completion of section 12.6, the other quadratic surfaces are explained in the video or the recording given in the Teams of the office hour. You go to the Teams of the office hour, and there you will see a recording. You can look at it, or you can download it, and you will have it contains the explanation of the other quadratic surfaces, okay. The second point, you don't forget you have a quiz this week on Thursday. It is a short quiz, 2 questions only. Make sure your position is okay. So you have to turn on your camera. Make sure the lockdown browser is working, okay. And for next week, for the exam of next week, the lockdown browser, make sure also the lockdown browser is working, okay. Because, well, maybe you will have the lockdown browser. You never know, okay. In exam 1, it was disabled. Maybe in exam 2, it will not be disabled. So you'll be required to have the lockdown browser. So all of this now, check them for every quiz and for every exam, okay. Now just let me